kids, welcome back again with me, Miss Dewi, in Math Year 3 from Ustazah Islamic School. Today we're going to learn the part 2 of symmetry. We're going to talk about rotational symmetry. What is it? So, what is rotational symmetry? We have known that one complete rotation is about 360 degrees, so one full turn. If we have a figure that have 4 sides, it will turn 4 times about its center of rotation. Each rotation will fit exactly to the center of square. So, rotational symmetry is when a figure fit to 2 or more sides of its center of rotation. Confused? Don't be. Let's do it one for figures with rotational and non-rotational symmetry. Let's relearn. First, we have an equilateral triangle, A, B, and C. Now, let's see what happened with the triangle if we move 120 degrees. Look, the A from up, it moves into here. So, then we move again. 240 degrees. Look, A from here, it moves 240 degrees, end up here, and then we move it 360 degrees. So this guy, A, will move 360 degrees to back into its position. In one complete turn, equilateral triangle fit exactly itself 3 times when rotated about the center. This is the center, the center, the center, the center. So, equilateral triangle has rotational symmetry of order 3 about its center. So, we call it rotational symmetry of order 3. Very well. Now, let's take a look. We have here the shape of diamond. Diamond A, B, C, and D. What if we move 90 degrees? Look, A moving here. So we call it 1 out of 4 turn. What about it move again? 180 degrees. So A move here. We call it 2 out of 4 turn. Or we can call it half 1 out of 2 turn. Now look at the A, we move into 270 degrees. So A from here, move it here. We call it 3 out of 4 turn. And then look, the A will move 360 degrees back into its position. We call it 4 out of 4 turn, or 1 full turn. So this diamond fit exactly 4 times to its center while moving. So diamond has rotational symmetry of order 4 about its center. It's 4 times move to its center to become fit exactly the same. Now the third, we learn about trapezoid. Look at this. If we move the trapezoid 90 degrees, is it fit exactly? No, 1 out of 4 turn is not fit exactly, so we cannot count. So what about this? It moved 180 degrees. It is half turn. 2 out of 4 turn. Is it fit exactly? Nope. What about now? When it moved 270 degrees. 3 out of 4 turn. Now let's see, it can move 360 degrees. One complete, it call it full turn. So let's take a look. In one complete turn, the trapezoid fit exactly only once when it's rotated about its center. Sorry, this is center, supposed to be here, here, and here, the center. So it means that trapezoid has no rotational symmetry. So if it only can fit exactly itself once, we call it has no rotational symmetry. Now we have here parallelogram. Look, how if we move 90 degrees? Does it fit exactly? We call it 1/4 turn. No, it isn't. What about 180 degrees? Yes, 2/4 or a half turn. It fit exactly. What about 270? 3/4 turn. No, it's not. Now let's move 360 degrees. We call it full turn, and it fit exactly. So it has 1, 2 times fit exactly on its center. Supposed to be center in the middle. So this parallelogram fit exactly 2 times, 1 and 2 when rotated about its center. So we can say it has rotational symmetry. So the parallelogram has rotational symmetry order of 2. Get it? So it has rotational symmetry of order 2 about its center. So conclusion, after we look at some example, we can conclude that if a figure has only once when rotated about its center, we call it has no rotational symmetry. Then, if a figure has 2 times or more when rotated about its center, it means that it has rotational symmetry. That's it. Do your best. Be the best of you. I love you. Wassalamualaikum warahmatullahi wabarakatuh.